Okay, last part. I'm going to create a lighting system from scratch, but for the geometry, I'm not going to make everything from scratch. Instead, I'm gonna use the operator snippets. And here in the pop section under the particles, there is a very nice example of using ray pop for the particle collision. It saves us some time, so I don't need to create geometry and the particle system. Okay, my plan here is to use these particles as a light source. So to assign the different colors for different particles and make this geometry be lightened by those particles. Okay, so here is under provided components, there is a calculator for the spherical lights. It's the same for the point lights, like we're gonna use here. And it needs light sources and the probes grid. First, let's gonna create the probe grid because I don't know which size and position I need for the grid. I only know that my grid should cover all geometry that would be lightened later. So here all geometry I need. By the way, to make this geometry a little bit more interesting, let's modify this one. Let's make it very simple, just a facet with unique points, and after the facet I'm gonna use extrude under the normal by some distance and maybe the taper. Okay, so our geometry looks a little bit different and more interesting now, I guess. Okay, maybe something else over this one. Another facet, but just a facet here. Okay. So for the grid, I don't need any connectivity, but I do need some slices. But I don't need the size of the grid. Here I can, okay, here I have the merge, and I could use it for my purposes. I can connect the grid here, and so I want this grid to cover all geometry. So I'm gonna move it a little bit down, set size here a little bit bigger, here also a bit bigger, and here as well. But also you need to keep in mind that we don't want to have super large grid, because for every point of this grid we're going to evaluate all of the lights. So we need to keep grid as small as possible, but also to cover all of geometry. By small I mean not the size itself, but also the number of the points. So I'm gonna reduce size a little bit. Okay, that's enough. That's covers. Maybe here 7. Okay, and here I guess 3 would be enough. Maybe even less. Maybe 2. Yeah. Okay. Everything is covered. And also I like to keep grid distance in between probe the same and all dimensions. It's not necessary, I just like it this way. It creates better shading. So we can use, maybe multiply these numbers by 5, so it gives us 30, 35, and this would be, okay, 13. Okay, now we have a grid. We can disconnect it because we use this merge only to create the necessary size for our grid, and we can connect our grid to our spherical lights. And here we need to connect only points. We don't need to connect the geometry. So we actually could delete this because we're gonna need separately the grid. Here is the lights and here's geometry, and we can actually pass it here, maybe to make it simpler. Okay, where is here? Okay, the new, let's call it lights particles. Here let's call it another node. Let's call it geometry, and here we have our grid. Okay, let's connect our light particles here to the calculator, and okay, now we have calculated light, but we can't see anything, of course, because we need to render it. First, okay. Um, Actually, the simplest way to render it would be to use this font material I showed in the practical session. So you could just copy paste it here. But it's a little bit more difficult to use this component called spherical harmonics only material, because it requires some settings to set up. So I'm going to show you how to use this one instead. Okay, it requires the probes. So here's our probes. It's going here. And it also requires the standard rendering setup, because what it does, it's only calculate the light, diffuse light from the spherical harmonics and make it as a separate render path that you can then output and composite with your normal rendering. So let's create a normal rendering setup with this geometry. So let's pass this geometry into geometry component. We also need rendering, a render top, and we also need the camera. And I like to use the camera viewport because it rotates really nicely, but it requires a little bit more settings. So let me go outside, and since our geometry is positioned more or less vertical, let's pretend that we're gonna create the vertical video for the Instagram or YouTube shorts, I don't know. So here's our resolution for the vertical video. I'm gonna use mouse inside, and let's look inside the out one top, which is not created yet. And so let's connect our renders somewhere there to output. And now we can reference the panel component here as me parent. Okay, now we could split our view and see it here as a panel. Okay, nothing is visible because nothing is rendered yet, because we don't have any camera. It's not referenced yet. Let's reference it. Okay, we can see something right now. It's not shaded correctly. It's not shaded at all, actually, because, and also we have some problem with proportion. Let's look at this first. Okay, here we need also to set the resolution to reference the parent resolution. Of course, it's all not necessary. It's just my way of doing this. You could totally do it manually. Okay, now we have the correct proportion. We don't have correct shading, so let's use the Fong shader for now. But we still can't see anything because we don't have any light. If you want, you could add some light. Okay, and now everything is right. But actually, I'm not going to use any just normal light comp because I only want to use my component for the lightning. Okay, here I also need to reference the camera, the correct camera, and now we can see something's going on. And let's composite the standard render with our spherical harmonics version. Let's use the add for now. Okay, it looks really ugly, but we're gonna do something about this later. Firstly, I want to make the particles visible as well. So let's create another geometry. go inside, and I'm gonna use just a normal point and use those particles as a instancing. So here I'm gonna use instancing page and use the same like particles as an instance operator, and let me set the positions and their colors. Okay, sorry, I don't have any colors yet. First, let's use the line material for this geometry, but we're not going to render lines. Instead, we're gonna render points, and I don't need specify far distance. Okay, maybe something like this. Okay, at least now particles are visible, and let's create some colors for them, because it's not because just because. Last time I did something similar setup. I used the here I use noise pop, but I didn't like the result because it was too random, a lot of random colors. So this time I'm gonna try to use lookup texture instead, and for the texture I'm gonna create the ramp. Oops, the ramp. Okay, and maybe I set new. Maybe I will need to change something here. For the top, I actually want to use just a long string, and we don't need a lot of colors here. RGBA fixed is fine, I guess. Okay, let's use the float to maybe calculate it more precisely, which in this case it's not necessary, but just let's do it. Okay, I'm not gonna create some fancy setup here. I'm gonna save time and just create some basic lighting. Okay, we reference our top, and we have only U attribute because we have only one pixel, and we're gonna use particles ID and normalize and return it as a color. Okay, now we have these waves of the color. Maybe it's and if I set to 2000, okay, or maybe we can also use this period to make these waves go in more or less frequently. Okay, also I would like to set it as a mirror. Oh, all right. Now we need to pass the colors, because now we have them. Color, color, color. All right, and let's do something about shading, because now I guess what's going on. Okay, let me clean this a little bit. Okay, I move all rendering here and all spherical harmonics related here. Okay, I would like to make it more saturated, but maybe a little bit less bright. Okay. Okay, maybe I'm gonna use, I could use the modifiers here. So I need to pass our probe data through modifier, and inside modifier I'm gonna HSV adjust with a little bit more of saturation. So maybe I could also create a bit more resolution for the grid. I'm gonna make a pause because it works better this way. Okay. Yeah, I guess with this resolution it works a little bit more, but we still can tweak a lot of these parameters, how you want these particles to affect everything. Also, I don't like that we don't have any shading going on here. Of course, we could make fall-off radius bigger or intensity in general, but we still I guess here we maybe, we don't have any particles here. Okay, uh, let's make our particle emitters move. Okay, abs time frame. All right, now it's better and it's easier to find better settings, I guess. So we don't, I want fall of radius not to be too big. And I also want to find this over too bright areas, and I could make it with the settings here in the material. I could use this row of parameters to move it maybe even higher. Okay, that looks fine, but we still don't have any colors underneath. And let's, because we don't have actually particles, because all particles are collide with geometry and there is not much particles on this side. So let me create the line. I'm gonna use circle pop, and I'm gonna place it somewhere underneath the geometry. So I'm again gonna use this merge to find a good position for my circle. Okay, I need this plane. I'm gonna translate it much here, and maybe I also want it to be like diagonally something like this. Okay, so what I want, yeah, I want this. Yeah, I guess something like this. Yeah, this should work. Okay, I don't need this line again. So now, because I have line, I'm gonna use the other component, which is called the line lights. And it's also required the grid and the lines. We have already our lines. I could connect it. And for the grid, because the later I want to add this both lights contribution to the single geometry, let me move again our geometry a little bit more. Here I need to blend it. And to make blend work, we need to use the same grid for the all calculators. Okay, here I can use our blend pop and set blend type to add. Sorry, there was some little problem with the frozen. Now it's unfrozen. I didn't do anything yet. Okay, I guess it was frozen because we have a lot of attributes and we actually only need these attributes. So we can delete all of this, and here we could use the she only, and it would work faster. Okay, and I also want to visualize the line itself. So for this, I'm gonna pass it to another geometry component, and I'm gonna use another line material, this time as a line. Okay, and maybe after this render, I could also set some bloom effect. A little less particles, a little more fill, a little more bloom. Yeah, something like this. And I want this line to be much more smoother. So, okay. And let's look, by the way, how it looks without without the particles. So if I turn off our particles, I can see that something isn't working now, right? Yeah. something isn't working. I guess it's because of fall off radius. Yeah, that's right. Okay, so now our lines is working and we can go back our particles. What? It's here. Yeah, sorry. I turn off the value here. So here, I don't know, fall off radius. Now, by the way, everything more or less is done, and you can spend hours of tweaking parameters and finding some good values that working for you. I'm not gonna spend too much time doing this. Instead, I want to show you something else that you could do, because I didn't explain much about how to use the analyzer and how this light information stored in probe can be used to modify some parameters of the system. So what I'm gonna do is I'm going to use this analyzer to analyze what we have. Okay, let's analyze what I want to do. I want this light to be brighter and maybe bigger when there is not much of the particle lights, and become much smaller when there is a lot of light from the particles. So I want to evaluate how many lights the geometry received before we contribute of this circle light. So I'm going to connect my analyzer not to the blend, but to our modified light from the particles. And I don't need all of the data from all of the probes because I only need one value, so I can use the analyze probe afterwards. And for the attributes, all I need is actually the intensity. And if I put it as a chop, actually I need only intensity and the last channel, because it's the red channel intensity, green, blue, and this is average. I need only average. Okay, and now I could use this value of this is like overall brightness for the all of the probes that catch only the contribution of these points. So now I'm gonna use this math when there is not much going on of the brightness contribution from the points. I want this circle to be larger and more brighter, and vice versa. So we need to set it moves like from 0 to 0.1 or something like this. Okay, from this range to, let's say, this range, or maybe this range. Okay, if I set it as a uniform scale, now my line should react to the amount of the light. How could I check it? And by the way, I could also use it as a multiplier for the intensity of the light. Here, the alpha channel is always intensity, so I could use it here. And for the checking it, if I, for example, here I make my particles much darker, or here if I make them much darker in the modifier, for example. So we don't have any contribution light from the particles, it doesn't light up, and our contribution from our circle become more, but it's still invisible because I guess we still have the problem with the radius. So maybe instead of using reference in this over here, we could reference it here, and the set color, set it back to 1. Okay, now if I change the amount of the value from the Why it's not working still? Because I didn't reference it, sorry. Okay, I guess now it's working. Let me check it also differently. If I, for example, I reduce number of the particles, for example, to just 100 particles going to birth, as you can see, the light from the circle become larger because now this circle light knows everything about, well, not everything, but the state of the probe inside the scene. And if I going back to 1000 particles, it start working better now. Yes, maybe 5000. Yeah, it's reducing, and maybe if I also set the particles much more evaluated, yeah, the light is reduced. So everything works as intended, everything nice. And as I said, it's I spent maybe half an hour building this setup, but I could easily spend next hour tweaking these parameters because I still don't like how it looks. Maybe I need to change the resolution of the grid, maybe some parameters of the modifiers or of the maybe also the component. I don't know. It's just many ways to play of and to tweak the parameters to find the look you like. But the point of making this system was to show you how to use all, or not all, but most of the components that I provide, and I hope that was clear. So that's it for the spherical harmonics for today, and see you in the next video. Bye.